Hi, this is Mrs. A of Mathematic. In today's video, I am going to illustrate quadratic inequalities. But please don't forget to subscribe to my channel and share my videos. What is quadratic inequality, by the way? Quadratic inequality is a polynomial of degree 2, which means the highest exponent of x is 2, that uses greater than or equal, less than or equal instead of the equal sign. The standard form is ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be equal to 0. Now, so here's the quadratic inequalities here in standard form: ax squared plus bx plus c greater than 0, ax squared plus bx plus c greater than or equal to 0, ax squared plus bx plus c less than or equal to 0, and ax squared plus bx plus c less than 0. So look at the inequality sign here. Let's have an example of quadratic inequalities in standard form. Okay, so x squared minus 2x plus 6 is greater than 0. This is the value of a here is 1, the value of b here is negative 2, and the value of c is 6. Now, I have here 3x squared minus 8x plus 16 is greater than or equal to 0. X squared minus 4x plus 10 is less than 0. And 2x squared minus 2x minus 7 is less than or equal to 0. So you need to check. In order for you to determine if it's inequality or not, means check here, the inequality sign. And then check also the highest exponent of x, which is supposed to be 2. Now, I also have an example here of quadratic inequality which is not yet in standard form. X squared minus 2x greater than negative 7. And this negative 7 should be on the left side. X squared plus 6 greater than or equal to 3x. 5x squared minus 2x less than 8. So we need to move this one on here. Same with 3x on the other side. And I also have here quantity x plus 3. This is in factored form, times quantity x plus 2 less than 0. So how would we know that this is quadratic inequality, which means the exponent of x, the highest one, is 2? Yes, multiply this, x times x, that is x squared. I have another one here. X times the quantity x minus 5 greater than 16. So here, x times x, that is also x squared. And the inequality sign here. Okay, so that's how you're going to determine if it's an equality, quadratic inequality, or not. Now, how are we going to write the interval notation or the solution? You need this before we're going to solve for quadratic inequality. So let us recall about the number line first. On the number line, this is 0. On the right side of 0 are positive integers. On the left side of zeros are negative integers. Take note that the number on the right side is always greater than the number on the left side. Let's say negative 1 is greater than negative 2. Negative 2 is greater than negative 3. Negative 3 is greater than negative 4. Okay, so now, the number line here is continuous to the right and to the left. So look at this. I have an open circle here, negative 1, and open circle in positive 2. These open circles here indicate that negative 1 is not included in the solution set, same as positive 2 is not included in the solution set. Okay, now here, going to the left, it's continuous, and that is negative infinity. and going to the right is positive infinity. Now, look at this one. The number line now is divided into three parts or three regions. Okay, from here, going to the left to negative infinity, from negative 1 to positive 2, from positive 2 to positive infinity. So three regions or three parts here, 1, 2, and 3. Now, let's say we are going to find the solution, and the solution is this part here. How are we going to write the solution set? Okay, let's say that's the solution set here. The open circle indicates that it's either less than or greater than. And if it is not included, you are going to use parentheses. If it's included, you are going to use bracket. I'm going to show it to you. Okay, so these are the three parts now, three regions. Here, from here going there, and from here going there. Take note, this one, negative 1 is not included, positive 2 is not included. Okay, so this one, if you're talking about this part here, this region here, open parenthesis, negative 1, comma, 2, close parenthesis. This is the solution set, if this is the area. So, parenthesis means negative 1 is not included, you just put comma, then 2, which means positive 2 is not included, so that is close parenthesis. Okay, what about here? Again, let's start with positive 2, and it is open parenthesis, comma, positive going to positive infinity, and also parenthesis. Going to positive and negative infinity is always parenthesis because it's continuous. Now, what about in this part here? Again, from negative 1, so this is negative 1, that I use parenthesis here, going to negative infinity, so negative infinity, and that is also parenthesis. Okay, so this is the solution set if we are referring to this area. This is the solution set if we are referring from this going to positive. And this is the solution set if we are referring to negative 1 going to negative infinity. Okay, let's have another one here. So I have here closed circle now here, solid. Negative 3 and positive 1. So again, this is from here going to negative, from negative 3 to 1, and then from 1 to positive infinity. Okay, so first for this part here, the solution set, if we are referring to this, can be written as bracket. Bracket means negative 3 is included in the solution set. So negative 3, comma, positive 1 because of this, and again a bracket, close bracket, because positive 1 is included. Here, what about from positive 1 to positive infinity? Since positive 1 is included, therefore, that is open bracket, 1, comma, and then going to positive infinity, and that is parenthesis. Positive infinity and negative infinity, that is always open. So it is continuous, so use open or close bracket. Or I mean parenthesis, sorry. It's always parenthesis. Now here, negative 3, start from here, that is bracket because it's included, up to negative infinity. Okay, that's how you're going to write the solution set, or are going to use the interval. notation. You want to try this? So I have here as solid, which means included. Okay, so first one region is from here going to the negative infinity, another one is from negative 3 up to 1, and then the other region or other part is from 1 to positive infinity. So that's the interval notation or the solution set. Open bracket, negative 3, comma, positive 1, close bracket. What about on this side? I have here open bracket, 1, comma, positive infinity, and that is parenthesis. And then here, I have here close bracket, that is negative 3, which means included. And then I have negative infinity, and that is open, and that is parenthesis. How about this one? I have here negative 6, open circle, positive 2, open circle. So negative 6, if you're referring to this area, that is negative 6, that is open parenthesis, comma, positive 2, open parenthesis. Now, referring from to going to a positive infinity, that is open parenthesis 2, comma, positive infinity, then parenthesis. And here from negative 6, that is open parenthesis here, so going to negative infinity. Okay, so that's how you're going to write the interval notation or the solution set. You need this in order for us to solve quadratic inequalities. And I'm going to show that on my next video, how to solve quadratic inequality. That's all for today. Thank you for watching and see you on the next one. Bye-bye.